Hello everyone, very good evening. I hope you all are good and doing great. So, today in the class, we are going to move ahead with electrostatics. So, let's first have a quick look over whatever we have studied so far in electrostatics. And after that, we will be starting with the today's topic. Okay? It's fine? Done. So far we have studied simple things, but still we have studied so much. First thing that we studied is conduction, induction, we studied in the very first class. After that, I will make you go through. So if there are two charges, system of two charges, then there will be force acting on these charges, and that force was given by Coulomb's law. So first we studied Coulomb's law that talked about the forces acting between the charges. If you talk about magnitude, then it was like Q1 Q2 by r ka square. K was something like 1 upon 4 pi epsilon. From here, we learned about epsilon, which is called permittivity of the media. And it basically defines how one charge is able to see another. So this is electrical polarizability. Okay. ये मैंने बताया. उसके बाद we studied like in which media epsilon is what? Epsilon is the minimum. ठीक है. So in which media it is minimum? Value of minimum epsilon is in vacuum, and that is indicated by letter epsilon naught. And in that case, value of K becomes 9 into 10 to the power 9. ठीक है. After that, we studied about electric field. So if there is any charge and at any finite distance r, if you're trying to calculate the effect of this charge, then we calculate that effect in terms of electric field, and we write that value as kq by r square for a point charge, right? Again, k is equal to 1 upon 4 pi epsilon. If it is vacuum, then it will be 1 upon 4 pi epsilon naught. Done it? After that, we studied about how to draw the electric field lines. So if it is positive charge, we draw electric field lines like it is coming out of the charge. Done it? So when it is positive, we draw field lines like this, and positive in isolated charge, then these field lines are straight lines. If there is another isolated negative charge, then field line will look like this. One more thing we studied, if value of charge is greater, then there will be more field lines coming out or entering onto the charge. Done it? And as we will move away from the charge, electric field will decrease. क्योंकि अभी अभी आप देख रहे हो, electric field is what? Electric field is inversely proportional to distance का square. So definitely as R is increasing, electric field will what? Decrease. Done it? And field lines cannot ever intersect each other. Reason being, if it does, then there will be two directions of electric field at a certain point. And second thing, electric field lines cannot form closed loops. Reason, if it is forming such sort of closed loop, it means from the same point, field lines is also coming out and also ending, which is not possible because at the same, if it is coming out, then charge is positive. If both is happening, charge ka status is quite unclear there. So you cannot make such sort of field lines like this. Okay? After that, we studied now we are going to study how to calculate value of electric field if charge is, if that is not a point charge. If charge is distributed in a certain space, then it may be the case that charge is distributed along the length. It may be case that charge is distributed onto the area. It may be the case charge is distributed inside the volume. So in all these three cases, we will be looking ahead at how to calculate electric field. So what things we are going to read? Let's say we have a rod, and it has certain length. Let's say this thing is negligible, width is negligible. So B is almost 0. B I'm calling width as B. So and it has certain value of positive charge distributed along its length. And if we are asked what is the value of electric field at certain distance r, how we are going to calculate it? Then, so whatever concept we will be using three basic terms time and again. one is your lambda, another is your sigma, and the last one is your rho. So what is this lambda? Lambda is basically charge per unit length. So if there is total charge q over here, then charge per unit length will be q by L. Okay. Similarly, if there is certain aerial sort of thing, and if charge is distributed inside the area onto the area, say like this, charge is like this, and if its area is equal to A, then we will define here sigma, and this is equal to q by pi r ka square, or directly write q by A, where r is the radius I have taken. Okay. Similarly, if we have a solid sphere, and inside that solid sphere, if there is certain form of charge distributed like this, so here charge density is written as rho, and this we define as q by 4 by 3 pi r cube. So these are going to be the things. Then how we will now calculate electric field because of continuous charge distribution. Now you're aware of these terms, right? Lambda, sigma, rho. So now let's say we have this thing. We have, again, I'm taking the rod back. So let's say this has a charge capital Q distributed, and at a distance r, we are going to calculate electric field now. So as you can see, we cannot write here electric field is kq by r square. This will be wrong. Why? Because this formula only we write for point charges, but this is not a point charge. Here charge is distributed along the length, so this one we cannot use. Then what we are going to do? So what we will do is we will divide this linear charge object into small element. So small that every small element will act as a point charge. So let's say I'm taking here this element, okay, of length dl, I have taken. Then, so this is a very small length, very small length. If it is very small, then we can say that whatever charge is here will act as a point charge. Okay. So now let's calculate the value of electric field because of this charge contained in dl length at point P. Okay. So what will be the value? Let's say the electric field value because of dl length charge is equal to D. So D को आप क्या लिखोगे? Since DE is like a point charge, first we will calculate charge onto it. So let's say linear charge density is lambda. So what is the meaning of lambda? You already know. This is charge per unit length. It means in L length, there is Q charge. So in unit length, there is Q by L charge. That is lambda. And so in DL length, how much charge will be there? Q by L into lambda. Sorry, Q by L into DL. ठीक है? क्या लिखूं यहाँ? DL लिख सकते हैं? Done it. So Q by L can be written as now lambda. So you will write charge in DL, that is small charge dq, is equal to lambda DL. ठीक है? So here lambda DL divided by, at what distance it is from the point P. Let's say this distance is something L. ठीक है? So lambda DL by L का square, K into Q is lambda DL divided by L का square. Everyone agree up to this point? किसी को कोई doubt है? Anyone having doubt in understanding so far? Let me know if yes. If not, then also you can let me know that you are understanding things. Yes. Anybody facing any issue? Madhura, okay. ठीक है, thank you. Okay, done. So D is this. Now, if we have to calculate the total electric field, then in integration you have studied, if you know a small value of certain thing, like here we know a small value of the total electric field at point P. है ना? This D is what? A small value of electric field at the point P. Done. So according to integration, if we know the small value, we can calculate the whole value by integrating. But can we do like this? Can we add it? When you integrate, you do scalar addition. When you integrate, you do scalar addition. Done it? And here, on one thing we have missed, intently I have done this thing. See here, at point P, electric field ka magnitude you calculated, but it will have certain direction also. So it is like this. And if you are taking element over here, the direction of electric field because of this element will be in this direction, and so on, right? So you cannot scalarly add like this. We cannot, right? Why? Because this electric field DE is a vector thing. So first, what we need to do is we need to break DE into one single. Suppose kar lo, all DE are in the same direction. Then we can add them scalarly. Because if all vectors are in same direction, suppose kar lo, there are 5 forces, 5 Newton, 10 Newton, 15 Newton, 20 Newton. What will be the value of total forces? You can scalarly add it, right? You can write here 30, 35, 40, 50 Newton. You can clearly write here. Why? Because all the 4 forces are directed in the same direction. But if there are one force in this sense, another in this sense, another in this sense, another in this sense, you cannot write the value of total force is 50 Newton. This will be a mistake. So here, same mistake we should not do, right? So we cannot add it like this. First, what we need to do is we need to break DE in such a way such that we will be getting such that we will be adding electric field vectors only in the one direction. So I will show you that. यहाँ पे मैं इस रॉड के डिस्कशन को यहीं पे एंड करती हूँ. I will show you further this thing with the help of ring. ठीक है? Done है? आगे बढ़ते हैं अभी. So how we will be doing electric field calculation because of continuous charge distribution. What I did here, first you need to pick the element. So how you will be picking the element? This is the first question. चलो मैं वो सिखाऊंगी एलिमेंट पिक कैसे करना है. So to pick an element, what you have to do is, if your charge is distributed along the length, always remember, if charge is distributed along the length, then your element will be some small length. ठीक है? If your charge is distributed in an area, अगर तुम्हारा charge, suppose कर लो ये disk है, then charge is distributed in an area, and in that case element will be what? In this case element will be small area. ठीक है? If your charge is distributed in a volume, let's say this is solid sphere and charge is distributed in a volume, then a small element will be what? Element will be here, small volume. ठीक है? अभी देखो चीजें, even if you are not able to understand completely, it is fine. As the class will move further ahead, you will be able to make sense of what I am trying to say as of now. So you don't need to lose your patience. You need to stick to whatever things I am saying. Just keep listening as of now. ठीक है? ज़्यादा जोड़ नहीं देना अभी. You don't have to, think more. Just pick the points what I'm telling. So picking the element. This way we can pick element. Second, calculate electric field because of element at that point. The thing I did here, since charge was distributed along the length, element that I took was a small length. Second thing what I did, because of that element, I calculated value of electric field at the point P, but with proper direction we have to calculate. Okay? So direction we have to mark. Second thing. And third thing, now integrate such that it covers the whole object. Now you need to integrate. But while integrating, always be careful, because you have to be careful in looking at you are not adding electric fields of different.
This meeting is being recorded.
Sorry. Okay, I will unmute him. Okay. Chalo, ठीक है. There won't be any disturbance now. So, while integrating, you have to be careful. What carefulness you have to look at? Just make sure you're not adding electric fields of different directions. Make sure when you're adding electric fields of the same direction. Now, I will solve one question for you here, one or two questions here, so that you can understand it completely. So now electric field on the axis of ring we are going to calculate. So we have a ring here, ring. Charge is distributed on its perimeter. I mean charge is distributed on the length. Okay? Ring means length. So here charge is distributed on the length, and at a point P from the center, we have to calculate electric field. First, first step क्या करना है? First step, pick element. Pick element. How we will pick the element? Since charge is distributed on the length, element will be a small length. So now I'm going to tell you, let's pick this element. This small length I have taken. Its value is dl. उसके बाद हमें क्या करना था? Second step, calculate electric field because of that element at the given point. So let's say here linear charge density is lambda. Then for calculating electric field because of this element at point P, that is second step, d value will be how much? K dq by, let's say how much is the distance. So यहाँ से ये distance small r ले लो. Let's say this is radius r and this distance of peak from the O is x. So k dq by r square will be equal to r square plus x square root under, ठीक है? Sorry, small r का value वो होगा r square. When you will do, root will get removed, ठीक है? Now we need to calculate dq. dq क्या होगा? Since linear charge density is lambda, charge per unit length is lambda. So in unit length there is lambda charge. In dl length, how much charge will be there? Lambda dl. Clear है? So this is the charge. Above value लिख डालो. T is equal to how much? K. dq is how much? Lambda dl divided by r का square you will write here. So this is what we are going to do, but we need to be careful with the direction. So देखो यहाँ पे I have added here the direction DE1. Done है? So this DE1 will have two components. If I talk about x-axis and y-axis, let's say this line indicate x-axis and this line indicate y-axis. Then this DE1 will have two components. One is along this direction, DE cos theta. Why I'm doing this? Because here DE is along this line. And if you're going to take another element, let's say I'm taking another element here. So because of this, electric field lines will have in directed in this sense, right? So we cannot add these two. We need to break it. So why not to do one thing? Break it into x and y directions. Add all electric field vectors of the x direction, then add all electric field vectors of the y direction, and then whatever electric field we are getting in the x direction, whatever electric field we are getting in the y direction, we will add them then vectorially. Okay? So we can do such sort of thing. That is why I'm trying to do this breaking. So DE1 first element यहाँ लिया था मैंने. DE1 को अगर आप break करोगे तो D cos theta is along the x axis because this is theta, and D sin theta is along the negative y direction axis. And let's say another element we are taking here. Here, this element is seen, this element is holding quite symmetry with this first element, right? How symmetry? Because its length is also dl, and also it is at the same distance small r from the point P. They will be, both the elements will be at same distance r. So if I say value of electric field because of second element is dE2, then magnitude of D2 will be same as D1 because its value is also going to be K into lambda DL divided by R ka square. So magnitude wise both are same. Again break D2. So if you're going to break D2, its magnitude of DE1 is equal to magnitude of D2, and let's say इसको मैं D से indicate कर रही हूँ. ठीक है? So if you're now going to break DE2, then component of DE2 along the x-axis will be what? If this angle is theta, this is also theta because both the triangle are same, right? So here you are going to get D cos theta, and here you are going to get D sin theta. So for these two elements, y components will get cancelled and only x components are getting added. Okay? For these two elements, only x component will survive. Similarly, you can take another element here and one more element here. So if you're doing anything like this, then their x component will get added, y component will get subtracted. Done it? So overall, if because of all the elements you will add electric field at point P, you will see that there is electric field only in the direction of x axis. That is only in this direction. Okay? So what does it mean? It has a simple meaning that for all such symmetrical elements, dE sine theta will get cancelled with another dE sine theta, and dE cos theta will get added. Okay? So if you have to calculate electric field because of the whole element, because of the whole ring, then we need to add d cos theta. क्योंकि ऐसे ऐसे इसमें और भी d cos theta ऐड होते जाएंगे, और भी d cos theta ऐड होंगे. Here more d sin theta will get added, and here also more d sin theta will get added, such that this will get cancelled with this will get cancelled with this will get cancelled with this. So basically what we have to do is we have to add dE cos theta, and that will give us the value of net electric field at the point P. Correct? Now, should we do it? So let's add dE cos theta. So small electric field at point P, I mean एक काम करती हूँ, किसी को डाउट हो तो पूछ सकते हैं, ठीक है? So let's add now dE cos theta. This is the value of small electric field that we have to add. So all small electric fields, if we will add, we will get total electric field, and this is equal to sum of d cos theta. So d cos theta, कैसे d का वैल्यू क्या है, d cos theta का वैल्यू क्या है, d का वैल्यू क्या था ये बताओ. d का वैल्यू था k lambda dl divided by what? This is r, this is x. Now let's write the values. R square plus x square. Okay. So this is d. What will be the value of cos theta in this triangle? If you look at here, this is r square plus x square. So cos theta is how much? Cos theta is x divided by root under r square plus x square. Okay. This is your cos theta. So d cos theta आप completely लिख लो. Write it properly. So this is k lambda dl by r square plus x square. This is d cos theta. Cos theta is x divided by r square plus x square का power half. ठीक है? Now integration हम करते कैसे हैं? Whatever is constant under the integration sign, take that outside. So यहाँ पे constant क्या क्या है that you need to figure out. Constant क्या क्या है बताओ. K is constant, ठीक है? K is a constant for a particular media, and lambda is a constant, right? What else is constant? X is constant or not? This point P is fixed, so its distance from the center will be constant, right? So here X is also constant. If X is constant, it means what else you need to take out? X, R is also constant, so R square plus X square. का पावर क्या लिखोगे? 3/2, क्योंकि this has a single power, this has a half power, though both are in multiplication, power will get added, 1 plus half, that is 3/2. So under integration sign, only thing remaining is dl, because dl is a variable. This dl you can take here, you can take here, you can take here, done it? So you have to simply add dl. Integration of dl means you have to add dl, done it? So addition of dl will be what? That will be equal to the length of this ring, है ना? Integration of dx, अगर dy क्या होता है? Y होता है. Integration of dl will be what? L. L is what? Length of the ring. So length of the ring is equal to how much? पहले आप इसको लिख डालो. So length of ring is equal to 2 pi what? 2 pi r. This is length of the ring. So this is the value of electric field you are getting. Done it? And the direction of electric field is along the x-axis. So if somebody asks you, अगर कोई आपसे पूछता है, there is a ring, ठीक है? There is a ring and on it there is a positive charge. अगर negative charge होता तो electric field का opposite direction हो जाता. ठीक है? So if there is a ring, let's say somebody is saying there is negative charge on its length. then what will be electric field at a distance x? So you will say electric field का direction is like this, and value you will write like k को एक काम करो, k को break कर दो, 1/4 pi epsilon naught लिख डालो. So if you are going to write 1/4 pi epsilon naught for vacuum, lambda x divided by r square plus x square 3 by 2 into 2 pi r. So this will get cancelled as 2. So answer will be how much? It will be x lambda x r divided by 2 into this. I mean, total you can write like this also in whatever way you want. So this is the value of electric field that you are going to get. Now, anyone has any problem in understanding, you can let me know. Yes. Let me know now. I'm giving you time. Get your doubts cleared because that is important. Okay? These are basic things. You should understand how you are getting it because later it will help you in solving things. If you know how to derive it, if you know how you're getting it, that will help you later in your problem solving also. That will boost your confidence. So even if you feel like how it happened, you're not able to completely get it. If you're getting it 80%, 90% like that, then after the class, you need to sit with a blank paper, and then take out your pen, start deriving it once more. Maybe that way you will understand it in a more better way. No doubts I got. Okay. पूछा करो, but if you have any doubt. ठीक है? This is homework for you actually. What you have to do, I have given you the value of electric field at point P. So first question is that find the point on the axis of ring where electric field is maximum. So you have to tell me at what distance electric field value will be maximum. So this is coming from how you calculate maxima or minima of the function. If I give you the hint, for that you need to do dE by dx equal to 0 first. Anyway, tomorrow in the class also I will make you understand this thing, but this is for now a homework. जिसको तुम्हें सिर्फ रखना नहीं है, you have to really try it. Please try it. And second, draw a graph between electric field and distance from the center of the ring. So E versus X का ग्राफ भी बनाना है. 2 टास्क है तुम लोगों का. अभी और भी होमवर्क दूंगी मैं. Again, for the full ring, we have calculated electric field at the center. For an arc, you have to calculate electric field at the center. I mean, if you calculate electric field at the center here, अगर तुमसे पूछता है electric field at the center क्या होगा, you will put x equal to 0, right? So, if you put x equal to 0, electric field will be 0. So here electric field at the center of ring is 0. ठीक है? For the arc, you have to see it will be 0 or not. I mean, it won't be 0. Ring के लिए 0 हो रहा है क्योंकि देखो whole length has a positive charge, है ना? So for any one element, if you are calculating electric field here, direction wise it is this. Then for opposite element it is this. So this is getting cancelled by this. Similarly, you can take such opposite elements covering whole length of the ring. So overall electric field at the center is becoming 0. Diagrammatically also it is becoming 0. Equation wise also you can see it is becoming 0. So for an arc subtending an angle phi at the center, you have to tell me what will be the value of electric field at the center. These are just for your more understanding. I want you people to really sit with these questions and try understanding concepts. That will help you more in boosting your confidence. So it's very important. You will do this question also. Now I will help you with another question. Okay? Yes, Madhura, that feels correct. Or maybe that is r by root 2, I guess. चेक कर लेना एक बार, ठीक है? Yes. ठीक है? चलो. चलो, now we will calculate electric field because of disk containing charge in its area at a point P. At any axial point we are going to calculate. Let's say what? Let's say radius of the disk is r and its distance from the point is x. First step क्या था? Pick element. एलिमेंट क्या लेने वाले हैं? यू पीपल सजेस्ट मी नाउ, व्हाट एलिमेंट आई विल बी टेकिंग? टेल मी, what element I'm going to take. It will be a small length, small area, small volume. What? No idea. Charge is distributed in the area. So small element will be what? Small area? Yes. I told you now, if charge is along the length, small element will be a small length. If charge is distributed in the area, small element will be small area. If charge is distributed in a volume, small element will be a small volume. So here, area, small area will be an element. But the question is which area, what area? Done it? So let's say we are taking here one element as, let's say at a distance of small r, from this point, we are carving out a ring of radius small r, and this ring has a thickness of dr. So this is the small element we are going to take. देखो, जब भी element लेते हो ना, previous case में what element I took? dl, small length. Whatever charge is in a small length, that charge will act as a point charge. And for the point charge, we already know what is the electric field at certain distance. What I'm trying to tell you is, whenever you pick element, for that element, you should have the formula of electric field also. So in previous case, we selected small length as an element. So that was acting as a point charge. And for point charge, we know how to write electric field. Here a small element, what I am taking? A ring of radius r of thickness dr. Okay? And just now we have derived formula for what is formula for electric field if charge is on a ring, right? Just now we have learned the formula. So we have formula for this small element. Done it? First step. Second, what you will do? So dA value will be equal to how much? This is a ring of length r and thickness how much? Its thickness is dr. So what will be its area? जैसे तुम एक काम करो, तुम्हारे पास सपोज यू हैव अ सर्कुलर रिंग, व्हेन यू आर ओपनिंग द रिंग इट विल लुक लाइक व्हाट? इट विल लुक लाइक this thing, and if it has certain thickness then it will look like this. So this will look like a thin rectangle, right? And rectangle का area क्या होता है? Length into breadth. So here its thickness is dr, that is breadth is dr, and what will be its length? 2 pi r. So small area is how much? 2 pi r dr. This is the small area. ठीक है? And because of this small area, there will be certain, because of this small element, there will be value of electric field at point P, and also direction we know. So because of this element, the ring element, electric field at point P is going to be in this direction. है ना? So whatever element you take, जैसे यहाँ पे we took one element of radius r, another element we can take somewhere here. Whatever element we are taking, for every element, electric field will be directed in this sense. Electric field will be directed in this sense. ठीक है? So if we are able to write DE, we can integrate it because all DE are in the same direction. So we can scalarly add them to calculate net electric field. So simple है, आप DE का वैल्यू लिख दो. DE का फॉर्मूला क्या था तुम्हारा? I need to go back and see. K lambda x, ठीक है? What's the value? Right here, K lambda x by, okay, let me do the thing properly. ठीक है? अगर तुम्हें याद हो तो हमने क्या लिखा था? K dq, small charge divided by r square plus x square, ठीक है, into cos theta. यही था ना फॉर्मूला? cos theta was r square plus x square का पावर हाफ, और dq के लिए हमने क्या लिखा था? dq was equal to lambda into dl. This is what we did for ring, right? Done. So if on a ring charge value is dq, we can write electric field like this. If there is a ring and this ring has a charge dq, then electric field at any point on its axis will be equal to k dqx divided by r square plus x square का power 3/2. This is what we can write. है ना? वहां पे हमने फॉर्मूला को पूरा ही सॉल्व किया था, dq को लैम्डा dl रखा, इंटीग्रेट किया, कंप्लीट निकाला. But for a small ring, we can write it like this. In terms of charge, we can write k dqx by r square plus x square 3/2. ठीक है. अब देखो यहाँ पे जो हमने स्मॉल एलिमेंट लिया था, this small element has a small area this, so how much charge it will contain? So it will contain sigma into dA charge, because sigma is its charge density. Done. So it will have how much charge? Sigma into dA. Done है. So dq is sigma into dA. अब आप यहाँ पे क्या पुट कर दो? k into dq is how much? Sigma into dA, and this is x divided by r square plus x square 3/2. अब एक काम करो, सारे वैल्यूज को लिखो. Whatever is constant, take that outside. K sigma by r square plus x square का power 3/2 is a constant. X here also is a constant. And when if you're going to write k sigma, x को भी constant बाहर ले लिया. dA का वैल्यू क्या लिखा है हमने? dA is 2 pi r dr. So here you will write 2 pi r dr. Again 2 pi is a constant, आप उसको बाहर ले लो. K sigma x डिवाइडेड बाय r स्क्वेयर प्लस x स्क्वेयर. ठीक है. 3/2 इंटू 2 पाई, एंड यहाँ पे क्या होगा? r dr. Now this small r is a variable, because if you are taking element very close to the center, r is small, and when you are taking element close to this perimeter thing, close to the boundary, then it is almost equal to 2 pi r. So small r is varying from 0 to capital R. So here you can take integration from 0 to capital R, and you can solve it now, and you will be getting the answer. So अगर मैं आंसर यहाँ पे आप लोगों के लिए लिखूं, तो आंसर हम क्या लिख सकते हैं? देखो यहाँ पे के को एक काम कर दो, ब्रेक कर दो. अब 1/4 पाई एप्सिलॉन नॉट इंटू सिग्मा एक्स डिवाइडेड बाई r स्क्वेयर प्लस x स्क्वेयर 3/2 इंटू 2 पाई है, एंड दिस इज r dr. r dr का इंटीग्रेशन क्या होगा? इसका इंटीग्रेशन क्या होगा? r स्क्वेयर बाई 2, एंड व्हेन यू विल पुट द लिमिट 0 से r, ठीक है, हाउ मच यू विल गेट? कैपिटल R स्क्वेयर बाई 2. सो यहाँ पे क्या लिख सकते हो? कैपिटल R स्क्वेयर बाई 2. दिस इज द वैल्यू, राइट? 2 पाई को आप यहाँ 2 से कैंसिल कर दो. सो दिस इज एक्चुअली वी आर गेटिंग सिग्मा एक्स R स्क्वेयर divided by 2 is here and also 2 is here. So 4 epsilon naught R square plus x square 3/2. Somewhere this answer may be given in terms of Q. So यहाँ पे Q के टर्म में नहीं, मैंने सिग्मा के टर्म में लिखा है. अगर Q के टर्म में है, then you can write sigma as equal to Q by pi r square. So you can replace sigma with Q by pi r square. You can write answer in terms of Q also. ठीक है. You don't need to remember the formula as of now, I would say, but yes, gradually with time, when you will be solving more number of questions, that formula should get fit in your memory. ठीक है. So what formulas we studied? We calculated electric field because of ring at a point P. Done it. We calculated electric field because of disk at a point P. And in both cases, अभी तक जो हम remember कर सकते हैं वो ये चीजें हैं. Electric field on the axis of ring or on the axis of disk will be pointed either outward or inward, dependent on which charge is there. If positive, outward; if negative, inward. ठीक है. अगेन यहाँ से भी एक होमवर्क मैंने दिया है. सपोज देयर इज सॉलिड स्फीयर, वॉल्यूम वाले पोर्शन को मैं लीव कर रही हूँ तुम लोगों के ऊपर, क्योंकि लेटर विद द हेल्प ऑफ गॉस लॉ वी विल बी डूइंग दिस ऑल कैलकुलेशंस मोर इजीली. ठीक है. इतना इंटीग्रेशन हमें करने की जरूरत पड़ेगी नहीं इन मोस्ट केसेस. डन है. सो देयर वी विल बी डूइंग दिस थिंग्स मोर इजीली. लेकिन इंटीग्रेशन को जानना बहुत जरूरी है. यू शुड बी अकस्टम्ड विथ लॉन्ग कैलकुलेशंस एंड एवरीथिंग, बिकॉज यू आर लेटर ऑन यू आर गोइंग टू सॉल्व मोर कॉम्प्लेक्स क्वेश्चंस or these complex things will get more easier if you really follow the things. So in this question, you have to calculate electric field at a distance r inside a solid, non-conducting solid sphere. Okay. Let's say here charge density given is rho. So you can use integration. This question I'm giving you just for you to practice integration. Otherwise, with the help of Gauss law, we will be doing it very easily. Okay. But Gauss law we cannot apply everywhere. I mean, for the case of disk, uh, I will help you do this question more easily also later on. आज के क्लास में मैंने सिंपल इंटीग्रेशन पे मैं गई हूँ so that you can understand what integration things and applications also. ठीक है. So in case you felt like कि calculation काफी lengthy हो रहा था, काफी अजीब सा जा रहा है, don't worry. What you have to do is first you have to practice two things that I have already done in the class, and then you have to follow with the homework also. That will make you feel like कि actually you have understood. So understanding को better करने के लिए you need to follow up. That is my point. Now we are going to read a very interesting thing, that is your electric flux. So electric flux को uh, how you can understand it more easily. Suppose kar lo, it is raining outside. Nowadays season, I mean rainy season is already coming. है ना? It is knocking on our door, I could say. So suppose kar lo बारिश हो रही है and you love rain. Everyone does, I guess. And you want to collect rainwater. There is so much crisis of water these days. So now even if we want it or not, we need to collect it. So it is raining, you have a container and you want to store water. Done. And you're taking that, you're having that container in your hand. How you will be able to collect more water? My question is how you will be able to how more water we can collect. Okay. So for more water, first thing what we will be doing, we will be taking a bigger container. So bigger container. है ना? And second thing, what is important is how we are keeping container against the rain. Suppose rain is falling down like this and we are putting container like this. We won't be able to capture any drop. है ना? पानी ऐसे ऐसे जाकर, it will simply slide down. If you want to catch water, catch raindrop to the maximum, we need to keep container in the direction of rain like this. Even if we keep it slight tilted, we will receive water, but not maximum. So two things we are seeing. First thing is size of container will matter, and second thing is how we are keeping the direction container. Yani ki second thing has to do with direction. So just replace the rain with electric field. Replace the rain with electric field. And then how many number of electric field is able to cross certain area or is able to is able to cross certain area will get determined by how bigger is the area and how it is directed with respect to the area. So that will be called electric flux. So number of electric field lines of force that intersect a given area is called electric flux. जैसे यहाँ पे देखो example दिया, this is electric field lines, arrow things, and this is area. Two areas I have taken. One is this one. Both have the same size. यानी कि container size is same in both cases. Area is same, but through first less number of field line is crossing, and through second more number of field lines is crossing. So here I will say more flux, and here I will say less flux. है ना? And why this is happening? Because area is oriented in a different sense in both the cases. In first case, area feels like to be in the direction of rain, and in second case, it is somewhat tilted. Done है? So flux को हम indicate कैसे करते हैं? We indicate the letter electric. We indicate electric flux by the letter E. Sorry, phi. इसको हम phi से indicate करते हैं. And what is the formula? Formula is E dot A. E dot A. यानी कि dot product of electric field and area. Here both electric field and areas are vector. ठीक है? So electric field का direction you can already see here. How to calculate the direction of area? So direction of area is nothing but it is taken to be the normal to the area. So see here, I have taken one diagram. If this is one, uh, this sort of thing, so what will be the area vector on this? It will be outward normal. So outward normal we take as the uh, direction of the area vector. So line perpendicular to the surface is basically the direction of area vector. Okay. So flux we will be writing as E dot A. Here, look here. This is the direction of electric field. This is the direction of area vector in this case. Angle between these two is theta. Then value of flux will be E A cos theta. Okay. So far, anyone is facing any issue? If yes, let me know. Yes. किसी को कोई problem है? You can let me know in understanding the flux. और किसी भी तरह का issue हो, you can let me know. हेमंत, anyone? Gauri? Others? Please please change your account name to your personal name or to the name of your Navodaya, please. That makes me easier to follow. Nandu. Somebody is using their title as user. What is this here? Sanju, Sri, Renuka, Ranju, Srinidhi. Everyone understood? Why people are so silent? देखो, in the school, when you are already in the school, I understand your silence. When you are sitting, some of you are sitting at your home. In that case, I don't understand your silence really. Okay, Madhura, that's great. Thank you. Only I received message from you. Others are simply silently sitting. क्या हुआ यार? बोलो, कुछ तो बोलो. एक गाना है ना हिंदी में, कब तक चुप बैठे अब तो कुछ है बोलना. बोल लो तुम लोगों भी. बोलते ही नहीं. Since then I'm talking, talking, talking. Don't you get tired of my voice? Must be. So in the meantime, you should also, I mean, say something. Hemant, thank you. Thank you. चलो आगे बढ़ते हैं. So in differentiation form, flux is what? E dot A. So if you are calculating flux through certain area and for each element of area, you are calculating flux individually, then sum of all those flux will be the total flux through surface, through that closed surface. Okay. So in differential form, you can write flux like this. Done it? So see here, this flux we wrote for what? 2D body. What this area is what? 2D thing, है ना? This area is what? It is 2D thing. ठीक है? So this is 2D thing. Now if you have to write flux for a closed surface का मतलब क्या होता है? 3D thing. जैसे solid sphere. So let's say there is a cube. Let's say there is a cube. And I'm telling you, there's certain number of field lines entering, but only lesser number of field lines going out. So flux through this area is because of 3 field lines. Flux through this area is because of 2 field lines. Total flux through the cube will be what? Flux through one surface minus flux through another surface. क्योंकि at surface A, flux is entering. At surface B, flux is leaving. So inverse flux को through closed surface में क्या लिख सकते हो? Incoming field lines minus outgoing field lines. Always follow your NCERT book, I would say. NCERT का I'm teaching you electrostatics. Now start opening your first chapter, chapter 1, and go through questions. ठीक है? Please do it. I've selected one question. Do this and let me know what answers you're getting. There will be more questions also, but first let's go through. Okay, I will launch the poll now so that you can answer there. You can also text me in the chat box, okay? So that I can understand who is getting it in what way. I mean, right or wrong, so that I can make you understand, right? Not to judge you. Don't worry. Okay, two wrong answers I got. Okay. श्रीनिधि एक बार चेक करो यार, फ्लक्स निकालना है. यू जस्ट चेक विथ डायरेक्शन. No correct answer so far. 7 answers I received. Check with direction. Venu, again, I would say check with direction. देखो तुम लोग मिस्टेक क्या कर रहे हो. What is question? क्वेश्चन को ध्यान से पढ़ो. Just don't look at the diagram. There is a square surface of side L meter in the plane of the paper as shown in the diagram, and there is a uniform electric field E acting along the same plane. So in the same plane electric field is there. जिस plane में तुम्हारा ये square surface है, in this same plane electric field is there. ठीक है. So question यहीं पे solve हो गया. Suppose this is the square surface. ठीक है. And electric field is in the same plane. Means let's say this plane is acting as an electric field. This plane. Okay. ये पेन तुम्हारा क्या कर रहा है, इलेक्ट्रिक फील्ड की तरह एक्ट कर रहा है. हाउ यू विल कैलकुलेट द फ्लक्स. फ्लक्स के लिए क्या लिखते हो तुम. वेनु नो. फ्लक्स के लिए क्या लिखते हो, ई डॉट ए. ठीक है. ई ए कॉस थीटा. व्हाट इज द एंगल हियर बिटवीन इलेक्ट्रिक फील्ड एंड एरिया वेक्टर. इलेक्ट्रिक फील्ड इज इन द प्लेन and area vector will be perpendicular to the plane. So it is perpendicular to this surface and electric field is in the plane. So both are perpendicular or not. Electric field and area vector here are perpendicular or not, because this electric field is in the plane and area vector is perpendicular to the plane. I told you area vector का direction क्या होता है, normal to the plane, that is perpendicular to the plane. So area vector is perpendicular to the plane, electric field is in the plane. It means what, angle will be 90 degree. So you just think like कि जो ये बोर्ड दिख रहा है ना तुम्हें सामने स्क्रीन पे जो दिख रहा है, that screen is your square surface. So and in that surface or on that surface itself electric field is there. This is the electric field on this surface. What is the area vector of this surface? Perpendicular to the plane. So either perpendicular to the I mean outward perpendicular to the board. Done it. So what will be angle between a line on the board and line which is perpendicular to the board? क्या एंगल होगा दोनों के बीच का, 90 डिग्री. So here angle between area vector and electric field is 90 degree. So flux will be zero, because if theta is 90, cos 90 is zero. So flux is zero. Got it? Are you able to get it now? Just look at the question more carefully. Again, I would say everyone thought like this is the angle. This is not the angle. This is simply a line in the plane of surface. This is not normal to the surface. Normal to the surface will be perpendicular to the surface. So angle between perpendicular to the surface and electric field will be 90 degree, because electric field is in the plane of surface. ठीक है. Any doubt anyone so far? नहीं समझ गए. Okay, Hemant, thank you so much. Chalo, this is the last question for today's class. This question is taken from your NCERT book example. Okay. So look at this question carefully, read it, try to understand it. We have some 3-4 minutes, so try looking at this. Okay. No, this light will not help actually. Okay. चलो कोई नहीं, दिस इज मोर बेटर. बी पोर्शन तुम्हें नहीं करना है ये. हम तब कर पाएंगे व्हेन वी विल बी रीडिंग गॉस लॉ. ठीक है. सो बी पोर्शन तुम्हें नहीं करना है. यू हैव टू ओनली डू द ए पोर्शन. सो द फ्लक्स थ्रू द क्यूब यू हैव टू कैलकुलेट. दैट वी कैन डू नाउ. कैसे निकालोगे? फ्लक्स क्या होता है? नंबर ऑफ फील्ड लाइंस क्रॉसिंग. फ्लक्स क्या होता है इन द फॉर्मूला वाइज? ई डॉट ए. So you just see here, Ey is 0, Ex is 0. So electric field along the y-axis is 0. It means there is no field lines crossing through this surface. There is no flux crossing through this surface. Top and bottom, no flux. Uh, Front and back also, no flux, because there is no flux in the z direction also. Sorry, there is no electric field in the z direction also. Okay, Hemant. Jinbi Navsari. Okay, bye bye. देखो जमाना ही बदल गया. So this is the thing. Now, if you see here, there is electric field along the x direction. So on this surface, electric field lines are entering. So what will be the flux entering if you calculate here, magnitude wise? See here, electric field and area vector is making an angle 180 degree. है ना? क्योंकि area vector is outward normal we take. डन है. इलेक्ट्रिक फील्ड इज डायरेक्टेड टुवर्ड्स द एक्स एक्सिस. एंगल इज 180 डिग्री. सो अगर फ्लक्स का आप मैग्नीट्यूड की बात करो तो ई डॉट ए, इलेक्ट्रिक फील्ड एट दिस पॉइंट इज हाउ मच? हियर एक्स इज इक्वल टू ए. इलेक्ट्रिक फील्ड इज अल्फा एक्स. हियर एक्स इज ए, सो अल्फा ए 1/2. सो इलेक्ट्रिक फील्ड इज अल्फा ए 1/2 into area into cos 180. ठीक है. सो दिस इज द फ्लक्स entering. Now what will be the flux going out? So flux going out is flux going through this surface. So here also again see what is the electric field here. Now let's check what is the value of x there. So if this is x, a, and this is a again, so here x का value क्या है? 2a. क्योंकि more a will get added as you will move from one end to another. So x is equal to 2a. Electric field value is alpha. 2a का value क्या लिखोगे? 1/2 into area into here electric field और area vector के बीच का angle क्या है? 0 degree. Cos 0. How it is 0 you can see, right? So this is the area. Outward normal will be in this direction. Electric field is also in this direction. Angle is 0 degree. Okay. So you know incoming flux, you know outgoing flux. You can subtract these two to get the answer. Okay. So I expect you will be calculating. Okay. Chalo, anyone having any doubt? If yes, then let me know. I'm here to hear you. Last some 1 or 2 minutes. If you have doubts, I can stay. If not, then we are good to go. But let me tell you one thing. Please, please, please do the homework. Please take the follow-up of things, whatever you have read today. Okay? Don't simply let it sit in your notebook. Done it? And do check the notes. Notes is there on Enable portal itself. So you will be getting there. Do check notes, do revise things, and please do the homework. Okay, Hemant, how 180? I will let you know. Let me do one thing here. I will delete this for you. So यहाँ पे ध्यान से आप देखो. What is happening on the first surface? This I'm telling as first surface. So what is happening here? There is electric field. इलेक्ट्रिक फील्ड इज directed along the x axis. Ex का value given है ना. Ex is how much? Alpha x 1 by 2. So electric field is along x axis. So this is the direction of Ex. So here when electric field is entering, its direction is where? Along the x axis. And what is the direction of area vector? Area vector is always perpendicular to the surface. And which perpendicular? Outward normal you will be taking. So this is the direction of area vector. This. So angle between area vector and angle between electric field is how much? 180. Done hai? Hemant, are you getting me? Okay. So similarly, if you look at the second surface पे क्या दिख रहा है? Outward normal is this. Done है? क्योंकि inward normal will look like this. For this surface, inward normal will look like this. This is inward normal, right? So here outward normal is this. Electric field is in this direction. So both are parallel. Angle will be what? 0 degree. Srinidhi notes is there on in the portal itself from where you're joining the classes. People are not able to access it. Srinidhi? Okay, thank you. ठीक है, ठीक है. Access it from there. Okay, everyone. Bye bye. Take care of yourself. Tomorrow we will be doing. First, I will be taking. I will be asking if you have done your homework or not, and then I will be moving forward with Gauss law and all. Okay. So now we are moving towards so much things. Thank you. Bye bye, Sanju. Bye bye. Thank you. Take care, everyone. Bye.